Hi there, we're KIT-11. In this video, we want to share what we are currently learning this semester in Robotics II. Throughout our activities, we learn with different components such as the servo motor, ultrasonic sensor, and I2C LCD. We will talk about how these components work, what we did during the activities, the challenges we experienced, and what we learned from the process. My name is Lanuza, and I will be guiding you through our reflection. Enjoy the show. Let's start with the servo motor. A servo motor moves to a specific angle instead of spinning continuously like a DC motor. In our activities, we program it to rotate at different angles based on the given task in the manual. During task 1, we used the instructor's sample code and uploaded it to the Arduino. At first, it felt simple: copy, paste, upload. But when we started modifying the angles and delays, we realized we were beginning to understand how the movement worked. However, we also experienced a problem where the servo only vibrated instead of rotating properly. Even though the code was compiled successfully, the motor would just shake. After testing and even replacing the servo, we found that the hardware can also be the cause of issue, not just the code. Seeing the servo move for the first time gave us the strong coder feeling. Because the code we modified produced real physical movement, that moment made programming feel real and exciting. Next is the ultrasonic sensor. This component measures distance using some pulses. It sends out a signal, wait for it to bounce back, and calculate the distance based on time. In our Robotics II task, we experimented with reading and displaying distance value. We observed that readings were sometimes inconsistent depending on angle and surface type. Instead of relying on single reading, we applied averaging and threshold to make sure the output more stable. Through this activity, we learned that sensors do not always give perfect data. We must process and filter values in the code to make them reliable. That experience improved our understanding of how real-world systems handle data. The I2C LCD was one of the most enjoyable components for us. Unlike a regular LCD with many wires, the I2C version simplified wiring by using only 2 data lines plus power. In Task 1 and Task 2, wiring was confusing at first because of the numbers of connections we had to manage before switching approaches. One wrong wire could prevent the screen from displaying anything. It took patience and checking each connection carefully. What made LCD fun was customizing it. We modified the code to display our names and different messages. Changing the output felt similar to modifying a simple print "Hello World" line. Small change in code produced visible changes on the screen. The LCD also became a debugging tool. Instead of always checking the serial monitor, we display values directly on the screen to monitor what the program was doing. In Robotics II, we realized that each component does not just work alone. They work as part of a system. For example, in the tilt alarm system, the tilt switch acts as the input. The Arduino processes that input using an if statement. If the tilt is detected, the output activates. The LCD display alarm. The LED turns on, and the buzzer sounds. If the system is stable, the LCD shows safe, and the output remains off. That whole process, input, processing, and output, is one complete system. In the parking assistant activity, the ultrasonic sensor measures distance as input. The Arduino calculates the distance, then based on the range, it activates different LEDs and buzzer tones. One sensor reading controls multiple outputs at the same time. In the dynamic message display, using a potentiometer, the potentiometer acts as analog input. The Arduino maps the value and selects which message to show on the LCD. Turning a knob changes the output on the screen instantly. Through these activities, we understood that system thinking means connecting components logically, not just wiring them physically, but making them work together through code and conditions. One of the biggest challenges was debugging code errors. Sometimes, even when we copied code directly from the manual, it wouldn't now work. We were unsure if we copied it incorrectly or missed a bracket or line. Small mistake caused unexpected errors. Another common mistake was forgetting to select the correct board or COM port in the Arduino IDE. We often tried to fix wiring or code only to realize the port was not set to Arduino. That taught us to always check configuration first before troubleshooting deeper issues. Servo jitter, LCD not displaying, and inconsistent ultrasonic reading forced us to test step by step instead of changing everything at once. These challenges improve our patience, logical thinking, and systematic debugging habits. One important lesson we learned is that small, incremental testing is better than making big changes all at once. Testing one component at a time made it easier to identify problems. We also learned that modifying existing code helps build understanding. At first, we relied heavily on provided examples. Over time, we began adjusting angles, messages, and conditions confidently. Robotics II shows us that programming becomes more meaningful when it comes controlling something physical. Seeing motor move and display respond make coding feel alive. Even though the process was challenging, it was also genuinely fun. In summary, Robotics II helps us understand how input, processing, and output connects to form functional systems. We learned technical skill, debugging habits, and the importance of careful testing. The journey was challenging, but it was also rewarding. Thank you for watching, and good luck to you all!